This is Pre-Algebra 2, Lesson 4.3, and it's a lesson on equivalent fractions. Now, if I said to you, in this aquarium there are 10 fish, although you can see that there's more, but let's just pretend. 2 of them are goldfish. What fraction of the fish in the aquarium are goldfish? Could you do that quickly, or would it take you a minute to think about it? So, a fraction has a numerator and it has a denominator. And so, if you have difficulty remembering, the denominator starts with a D. It's down below, and the numerator is the opposite of that. And a fraction, we say that this is a fraction, but we also say b cannot equal 0. Now, you could write a number 4 or whatever, and you can assume that this part we just don't see, because that would equal the same thing there. Now, fractions that are used to describe equal parts of a whole, and when they represent the same part to a whole, they're called equivalent fractions. So you recognize these charts. We have 1 whole, we have 2 halves, we have 4 quarters, and we have 8 eighths. So here I've made some diagrams. Here is my fish that are in the aquarium. I have two goldfish and 8 bluefish, and altogether I have 10 fish. Over here I have done a fraction, and I have the number. I would put the number of goldfish on top and the number of fish, and here's what it works out. We have 2 goldfish, and altogether there is 10 fish. Now I could do another equation where I look at the number of groups of 2 goldfish. So I have groups of 2 goldfish and number of groups of 2 fish. Okay, so the number I have over here, I have 1 group of 2 goldfish, so that matches with that. And how many groups of 2 fish do I have all together? I have 1, 2, 3, 4, 5. So I have represented the same aquarium in 2 different ways, but this fraction and this fraction are the same. In fact, if we simplified this one, we would get to here, which is the same as that. And that's equivalent. It's the same fraction, just representing it a different way, but exactly the same thing. This is 2 groups of 5. This is 2 goldfish out of 10. So if I ask you to write 2 fractions that are equivalent to 6 over 8, how might you do that? So you could multiply or divide the numerator and denominator by the same non-zero number. So that means it can't be 0, but it could be 1, 2, 3, whatever, to find an equivalent fraction. So let's look at this. We have 6 over 8. I could multiply it by, on top and bottom, by 3, let's say. And when I do that, 6 times 3 is 18, and this is over 24. I could also divide, and let's say I want to divide this by 2. That's a common factor for both. I have to do it to the top and bottom, and then I get, oh, sorry, wrote 6, not 4. 6 divided by 2 is 3, 8 divided by 2 is 4, and these are equivalent fractions. And we can even test this further by saying if I reduce this, so if I divide both sides up here by, let's say, 3, I'm going to get 6 and 8. And if I divided them again by 2, I would get 3 and 4, which is exactly the same thing as that. So this is showing you that you can write you can write the fractions. It's equivalent. This is the preferred version once we simplify it, but this is representing the same thing here. Alright, I turned on. I'm going to go to the next screen. Didn't mean to confuse. Now, the simplest form that we normally want to get to is where we can't divide the numerator and the denominator have 1 as their greatest common factor, meaning you can't, 1 is the greatest common factor and 3 is 1 is the greatest common factor between the two. And we do this by simplifying a fraction. So let's look at doing 8 over 28. We can, so we want to find the greatest common factor here that the two have. In this case, it's going to be 4. So that means 4 times 2 is going to equal 8, and 4 times 7 is going to equal 8. And we can reduce that. So we end up with 2 over 7. Let's try another. We have 8 over 15. Well, there's no factors of 8 that match with 15. We have 8 times 1. I would have 2 times 4. And on 15, I have 15 times 1. I would have 3 times 5. That's it. So there's nothing here. The only factor that the greatest one they have in common is 1. And so here the GCF is 1. That means that this is the simplest form it can get to. If we go back up here and look at this one, we also know that 2 and 7 are prime numbers now, and their greatest common factor is going to be 1 because there's nothing else, no other factors there. Let's try some more examples. We have 1/6. So with 1/6, let's see, I could do I could multiply both the numerator and the denominator by 2. That would give me 2 over 12. I could do 1/6. Oh, shoot. Crummy. Okay. Times 3, and I would have 3 over 18. We have those are equivalent fractions. These will reduce down to this in its simplest form. Let's look at 3 over 10. Again, I can do 310 times 2. times 2, I didn't do that x very well. That's going to equal 6 over 20. I could do 3 over times 3. Shoot. That's going to be 3 times 3 is 9. 3 times 10 is 30. And these are equivalent fractions. This is in the simplest form. There's no any factors there that are the same, and those are equivalent ones. So to find equivalent for 8 times 18, we could just keep doing it's 8. We could try 2. 8 times 2 is 16. That's going to be over 36. We could try it with 3. And we end up, or actually we could divide. Let's try that. Let's try dividing. Oh, sorry. Add a little bit of excitement here. So let's try that. We have, we could do 8 divided by 2 and 18 divided by 2. What happens when we do that? Well, 8 divided by 2 is 4. 8 divided by 2 here is 9. And now we have equivalent fractions. So we multiplied by 2 and we divided by 2. And it stayed the same. And you could keep going. It doesn't matter as long as you do the same thing to the top and the bottom with the same number. You're not really changing the fraction. Let's say at a girls' basketball game, the home team made 14 out of 22 free throw attempts. The away team made 10 out of 25 free throw attempts. So write the number, if you can, on your piece of paper. What would be the number of free throws made by each team as a fraction? And are the fractions equivalent? So let's see what we got. We would have free throws made and free throws attempted. For the first team, they made 14 and they attempted 22. And the away team made 10 and attempted 25. Now let's look and see here what we can figure out. On to reduce 14, we can take the GCF on that one would be 2. That's going to be the largest factor. So that would leave us, that would be 7 times 2 and 11 times 2. Take those out. That leaves us with 711. Over here we're going to have 5 is going to be this GCF. And we can then eliminate that. And so over here we end up with 2/5. So 711 does not equal 2/5. These are not equivalent fractions. They're not the same. And by same means that you can't simplify them to get to be the same thing at all. They're through here. This is their simplest forms and they do not match. I never could have goldfish because my cat would always try to get into there to the extent that he would even knock down the goldfish. Your lesson assignment is on page 171 to 172. You need to do exercises 1 through 6, 14 through 21, 40 through 45. That should be about 20 problems that are due today. If you can't get it done, it's homework and it's due at the beginning of the next class period. Just a question, has either one of you, any of you, eaten a goldfish?